Okay. So I think we got a few people in here, so we can probably go ahead and kick this off. So with that being said, thank you everyone for joining in on AWS Meetup Group based out of Denver. So today we have a couple guest speakers, Drew Khoury and Chris from Contino have joined us to talk about a developer experience in a cloud native world and how to optimize that. With that being said, Andrew, I'll go ahead and turn it over to you.
Amazing. Thanks very much, Kevin. We're very excited to be speaking and demoing today. Like you mentioned, I'm here with Chris Hart, and we're going to be co-presenting. Chris, are you able to share screen?
Could I get screen share permissions, please?
Yes, 1 second.
Amazing. We love a little bit of interaction. So while that's happening, feel free to ask questions if you have them. You can do that through the chat in Zoom, which we'll monitor. You can put your hand up on Zoom, or even just ask a question if you're really interested as we're going. And we'll try and make it fun with a few jokes and tidbits. But I hope everyone's excited to be hearing about cloud native and about the topic of developer experience, which is really what we wanted to hone in on.
All right, I've got the screen up now.
Amazing, cool.
Looks great.
Awesome. I'm going to bring you to me, Chris, so we should be able to move that and follow along. Yes, I'm controlling the presentation. I always like to find a fun comic. I think this kind of represents the theme of what we're talking about today. Your typical CI/CD pipeline with 100 different steps and a bunch of automation everywhere, but probably convoluted and difficult still to get to production. So we're going to talk to you today about a few things. So I'm just going to give you the quick sort of agenda. I'm zooming all the way out so I can have a look personally at my agenda items. So I'm going to share with you, from our perspective, the evolution of cloud over the last 10 years. Explain to you what we mean when Chris and I talk about cloud native in this context. We're also going to talk about developer experience, what it is, why we should care about it. And we're going to share how we think sometimes some cloud native adoptions fall short of this developer experience that really helps us sort of get moving quicker. So without further ado, and if you don't have any big objections or questions, I'm going to zoom right in and sort of continue on with the presentation. This content, the following slides are actually by a website called Hackanoon, which the site actually took these slides down after some period of time, but I thought they were awesome and was able to capture them. So let me take you on a journey of the cloud starting in 2010. This is kind of what we're saying, like a typical establishment was like way back then. All your business logic, all your data, all your infrastructure and services were provisioned yourself. You had to oversize provision your infrastructure to deal with any scale that you needed, and you had a large team. So I'm going to fast forward here a little bit. So some years later, the cloud happened, and AWS definitely sort of led the charge on that. And here, what we see is it's just about the same, although because our demand could be on, because our infrastructure could be done on demand, i.e. because Amazon produced EC2s that we could spin up and tear down, we were able to have the same infrastructure, but we could decide when we had it, when we scaled our provisioning of it. You see here the team got shrunk a little bit because it was much easier to provision and manage our infrastructure. We didn't change the sorts of services that we had. And I'm going to zip past and have a look at a slightly different stage in the future. We have something like software as a service, where email or payments could be externalized, so we could have even smaller teams managing even less infrastructure. So that's great, smaller and leaner teams. And I'm going to zip right past to 2015 onwards. And this is really kind of where we're talking about the explosion of services and services like cloud native services like serverless, whether it's functions or backends as a service. And you see here, we start to entertain the possibility as an organization that you are only worried about a thin slice of your business logic, and you can offload a lot of the responsibilities of infrastructure management onto the cloud, as it were. And if you think about this picture in terms of where we started in the diagram to where we are now, this is a very different way to manage infrastructure than what we were all doing in our data centers about 10 years ago. When I talk about a journey of cloud, that's like one of the most succinct ways that I found to explain that 10-year journey. But I do want to dig into now that second part I promised you, and I want to explain what the fudge I think cloud native is and why you should even care. I thought I would do a gut check and see what Wikipedia has to say nowadays about cloud native. And if I was to summarize it, containers, microservers, and serverless, the keywords that pop up. There's a few other ways that I like to sort of level set on cloud native and what we think it is. If we think of infrastructure as a service, like the servers, the networking, the load balancers, to a certain degree, there's a sense of assembling all these things before you can deploy your application. If we look at the other side of things, the software as a service, like we explained, this is really awesome because you can just pay money for the problem to go away, right? You're not going to configure any software yourself. You're not going to write any of the code for the software yourself. You have Stripe, you have SendGrid, other services there. Cloud native that we're talking about, focusing on here today, is where we want to focus more on the deployment of your code, but we really just care about writing some code and having all of the other infrastructure managed, very little configuration that we have to worry about. And that's where we enter terminology like serverless, platforms as a service, functions and backends, etc. I've got a few more diagrams that I'm going to zip through, but really just to give you a few other perspectives on what some of you might already know or some of you are excited to hear about. But functions as a service, the most obvious one, particularly in our AWS world, is Lambda, right? And we're going to be demonstrating Lambda today. But all the other clouds might even have other services there as well. Backends as a service is a way to describe highly scalable databases, or services that contain a lot of data or backends. I shouldn't say just databases. And the platform world, there's AWS Elastic Beanstalk and a number of other platforms, and Kubernetes is an orchestrator which can be considered a platform. Heroku is a famous platform as well. So there's a lot out there, but this is the world that we're talking about. We're not necessarily today talking about the traditional networking and EC2 servers and managing the whole operating system yourself. There's a huge distinction there between that. And actually, I'm going to zip over to my favorite example, because what presentation would be complete without a talk that mentions pizzas? And yes, I believe pizzas do, pineapple belongs on pizza. So it's very controversial, I know. But if you haven't seen this model before, it's the pizza model and the self-service model, which shows you that as you move from left to right on this diagram, more and more of the stack, your infrastructure, is managed for you by the cloud provider or by the vendor. And the key takeaway here is the more that's managed for you, the better off you are in terms of how much of a team you need, how much configuration you need, how much you have to worry at night whether something's working. You are giving away a sense of control and configuration and customization for that. So there's this kind of like balance between how much control do you need at these layers and how much are you willing to offload. And so serverless and cloud native kind of sits somewhere in the middle there, not smack bang in the middle, but certainly kind of wedged between on-prem and then infrastructure as a service, which is kind of really just a repetition of on-prem in a more scalable way. And then on the other side, software as a service is the extreme. So we're talking about this middle part here. So let's see how we're going for content. So I've been able to blitz through this in 10 minutes. So we get to go through, you get subjected to more memes and a few more bits of talking before we get into a fun demo. But I want to talk about now developer experience. Since we know cloud native, got that level set, now we want to talk about developer experience. I really don't know exactly how this meme should work, but I made my version of it. So developer experience, there's a few things to talk about. We are going to focus on feedback loops, and we're going to focus on testing actually as well. These are important aspects. But we might let our customers test in production for us, meaning we don't have any testing. We might have a whole QA team that does all the testing for us. Maybe we test in the pipeline, or the ultimate, we should test locally. And testing locally was meant to be the epitome of software development Cloud Native came along and it got difficult to test locally with Cloud Native. Chris and I are going to try and convince you today that it's possible. And not only is it possible, you can have a really, really nice experience with fast feedback, just as good as any other kind of development with Cloud Native. I feel like I'm trying to rush through to give us lots of demo time. So I'm going to take a beat. I'm going to take a moment.
Hey, feel free to post questions in the chat as well.
Questions are great. And I know there's a few people that know me on here, so I'm surprised I haven't got any smart ass questions coming through, or some insightful ones from friends and colleagues. So feel free to pop those through as we go. Okay, what we've got here is actually a straight copy paste from Martin Fowler blog. And we're going to actually send through some links after this if you want to dig deeper. But Martin Fowler explains developer effectiveness. And one of the things I wanted to highlight here that you might be able to see, and maybe I'll zoom into it just a little bit more, is that there's all sorts of feedback loops we're going to talk about. And so one of the feedback loops we're going to focus on is validating a local change. Validating a local change should work. And actually, as per this definition, 2 minutes is a very long time to validate that your local change works. So our expectation for developer effectiveness, for developer experience, and for high effectiveness, it's going to be 5 to 15 seconds. If we can make a local change and have some sort of feedback, some sort of validation within 15 seconds or 5 seconds, that's good, highly effective. If it takes 2, 3, 5 minutes, then we're going to deem that as being too long for a local change. And this is why we have such a focus on testing locally, because it's one of the best ways to get down to that 10, 15 minute mark. There's a whole host of other types of feedback loops. And we might talk about some of those if we have time. There's also a bit of a visual about what happens when we kind of layer on and stack on delays, lack of automation and other things. It can take a long time to push changes through in environments that don't sort of support this fast feedback loop concept. So let's have a look at what we have here. And hopefully you can see there's 2 paths here. Hopefully you see which path we should be taking. These are examples of like a typical day from the Martin Fowler blog about developer effectiveness. And I'm going to go through the high effective one real quick. So you might start your day attending your stand-up that doesn't go for more than 15 minutes. You can pull down your pipeline and pull down new changes on that, and your pipeline is green by default. You might quickly make local changes on your local environment and do some unit tests. Excuse me. You might need to go to a developer portal to pull up an API or a spec from another team, but you have everything you need at your disposal without necessarily needing to go to another team and consult with them before getting going. Your workday is uninterrupted. You have several hours of flow and context, and you don't have it broken up by many, many status meetings. You get a coffee because you can, or you play foosball, or you enjoy parts of the day that you want to or that you need to, and you can commit code at the end of the day or throughout your day. There's automated tests and you're deploying that to prod. You have working software deployed to production multiple times a day because quality and automation is built in, and your team has an obsession with fast feedback loops and improving developer experience. And we're happy and life is good. Now, on the other side of things, as you can imagine, our low effective team starts off their day with alerts from production. They have to manually check some logs. And essentially what they're doing a good portion of the time is proving to the operations team that this is a false positive. And they didn't even have to deal with that. It wasn't part of their own software. So they're already kind of off the bat distracted. Actually, sorry, I've got a question here. Chris, have you read through that last comment to see if we should? You're on mute, Chris, there. I'm just having a quick read myself.
Yes. I was going to wait for a stopping point unless we want to stop right here and respond.
Oh, let's do it now real quick. We've got time.
Sure. So Christy is asking for introductions. Sorry, we forgot to do that. Drew, do you want to go first?
Yeah, sure. Hi, I'm Drew. I'm Andrew Khoury. I'm a technical principal at Contino. I've also had about 7 to 10 years of consulting and cloud experience. So lots and lots of tinkering with cloud automation from a development background and perspective, and currently leading teams at my consultancy that help developers become more effective every day through these kinds of techniques.
Hey, I'm Chris. I also work at Contino. I'm a DevOps consultant there. I've been a DevOps engineer or an infrastructure engineer for the past 5 or so years. And I've also done a number of serverless projects on the side too. So I've worked with, from, working with auto-scaling EC2 instance, clusters, all the way through fully serverless applications and focusing on developer experience and fast feedback loops.
It's a good call out to the intro in the background. I was just reading the other part of the question. We often work with large enterprises. We also have, side projects and other things where we have worked and do work in smaller teams as well. So we've got a little bit of a mix of both. Lots of our perspectives and struggles usually come from how difficult things are in large organizations. And Martin Fowler is someone we've based a lot of this content on in terms of sharing that out. And I believe he's got a similar sort of background in terms of having worked in larger organizations. It's a really interesting read, so we'll share the blog post out. He talks about the fact that he has observed these things, these feedback loops and thresholds to be possible even in larger organizations. So not just for startups, not just for 3-person teams. It is possible in larger organizations, but bureaucracy and silos often do get in the way. But there's no other reason why it couldn't work too. Okay, good segue. Definitely should have remembered that, but we learn day by day. I'm going to see if I can get through the last part to show you why all these people are crying these little emojis, because there's a good reason. So if we look at the low effective team, and this is really just an example of a team that you might see out there, right? An amalgamation of an archetype of teams, is that we started off with this distraction, almost like needless distraction, because there wasn't sort of enough automation here to figure out the scope of what was our team's issues, right? Also, when this team needs to do work on another API, they happen to need to talk to a project manager who sends them off to someone else, because there wasn't enough information between teams that develop their APIs about how to get started, right? It wasn't something where they could just pull down someone else's repository and just get started using it without having to interact with another team. So they're a little bit blocked on that for the day. They try and move on to something else. To get their changes through, this team has governance. And I've already forgot my acronym. Governance is a roadblock is what they have, right? So they have governance teams that they need to meet with once every month is the only time they can meet, once every 2 weeks. And they're kind of going through it for the sake of it. There's a lot of red tape happening in this organization. So they can't go through without a lot of manual and siloed teams checking off some things for them. And in fact, because of the way they're working within teams, the lack of automation, lack of confidence in their builds, their day's broken up by status meetings for people who are just looking for some confidence about how things are going, because that's the primary way that this team can get their updates. They have a previous feature that's been approved by their GAR, by their governance as a roadblock. And now they have to context switch to that, send out a nightly build and hope that the QA team can run the nightly build, or that the nightly build gets run before they can deploy something. So they're crying because they haven't deployed anything today. And developers that are not deploying multiple times a day or every day, or even, let's be honest, with some of these teams once a week, they're going to be struggling with the context switches, the feeling that they're not making progress. They have all these things that we've kind of listed here: toils, distractions, roadblocks, not enough quick feedback loops, not enough automation there to really be able to make progress. And we're this description of teams, hopefully thinking in your head, maybe you've been part of one team, maybe you've been part of another, and some of these things are resonating with you. At least one of these have to resonate. And hopefully some of you have had some time in the green.
I'd like to highlight that bottom team. It really, eats at that original promise of the cloud, that things are going to be faster, more agile. It's going to be easier for us to get to that good place of multiple deploys a day. But it's so common to see that bottom pattern in the cloud. We're only deploying once every 3 weeks or once a month or something like that, with a 1 week code freeze or whatever. It's such a common pattern that we see. It doesn't have to be that way.
I love the setup. It does not have to be that way. We have a solution, right?
Yes.
And we're going to introduce you to micro feedback loops and why we believe they're important. We're going to do that through a demonstration of a repository, a cloud native repository. We're almost there, actually. I've got one more section of emojis and fun icons, and then we're going to hand over to Chris, who's going to give us an awesome demo. So the question now is like, where do some of these cloud native adoptions fall short? Like Chris was saying, just because we've got this awesome technology now, it doesn't mean we don't run into these roadblocks. So one of the things now that we've set up with cloud native of these like low effective teams or situations is that even though cloud native is an improvement, from 2021 in terms of going from weeks or hours or days to potentially an order of minutes, 5, 10, 15, 20 minutes to run things, we're seeing lots of teams that don't have a local setup. The local setup that they do have, if they have it, isn't able to test multiple components, multiple lambdas or a lambda and a DB talking to each other. The lambda function is not tested before it's checked in. If it's tested, maybe it's tested manually by copying and pasting the code from the lambda function into the console. I've definitely done that before for quick and dirty solutions, but that gets unmanageable and is not the fastest feedback in a longer term team that's using Lambda in production. They may be missing out on things like S3 buckets, SNN, all the sorts of AWS infrastructure, AWS serverless infrastructure that you might have that is really difficult to test locally or previously has been a bit difficult to get set up. And even if you have made a very solid attempt to do that, you might have shied away from that because there's serverless tooling that you need to install and configure and get right. And there ends up being more than you expect just to get a, quote, what would be a quote simple a local replica of your serverless infrastructure on your laptop. So I hear you say, why, Drew? Why do we even care? Minutes is good. It's much better than hours and days. Surely this can't be bad. And it's not bad, but it could be better. And what we're proposing to you is that in 2022, we want to go from minutes to seconds for feedback. We want to say, even if you're in the cloud, even if you're using cloud native, actionable feedback in seconds before I commit code is the ultimate goal for a high performing team. It's this micro feedback that is going to make me enjoy writing code, enjoy coming to work every day, want to get more done, as opposed to try and batch things up to the one release, or batch things up to a branch, or batch things up to a commit and hope that I can go and get a coffee in the 10 minutes it takes for my pipeline to run. So we don't want that situation. We don't want to get a coffee because I'm queuing up waiting for work. We want to get a coffee because I've done so much work and I actually have the time and space to do that, right? I love coffee, so all of my examples are coffee based.
Make sure you mention how much you love instant coffee. That's Drew's favorite.
I was wondering whether we should do this talk together, and now I'm second guessing that. I'm just happy that you don't have the instant coffee there as a prop. I'm hoping that you don't have it there. But anyway, let's have a look at what we have for you now. So a bit of a visual. I'm not going to try and go into detail for this whole crazy diagram, but what we wanted to try and do is show that the developers here on the left have this pipeline or path where they could be getting feedback when they save their code. They could be getting feedback on a local deployment, or they can commit their code, get a little bit of feedback there from some initial tests. They can deploy it to a cloud environment, and every time I go further down this line, deploy to a prod-like environment, deploy to prod, it gets longer and longer and longer. The feedback takes longer as we go from left to right. So if you imagine this typical pipeline from left to right, like I've described, we're gonna come in and show you this first section here, really focusing in on that micro feedback loop. So the sorts of things that you could be doing locally for any project that you have is, obviously, while you're coding, we could be looking at syntax and linting on save. We can even be looking locally at trying to build our software, seeing if it fails a compile, If, for example, any of these stages fail locally, then we know that we don't want to commit the code and push the code. It's going to fail. We want that feedback in seconds, not commit with a message, push, see if you get that right or wrong, wait for your pipeline to pick it up. We could be saving actually precious minutes on that, right? But we can go even further. We can do local deployment. This could include some sort of smoke test. We could be debugging in our browser. We could be mocking other services locally. And all of that gives us much more feedback and feedback that we should be able to get quicker than, again, committing and deploying to prod. I see a question there as well from Matthew.
Yeah, Matthew, do you want to read your question out loud, or would you like us to read it?
Yeah, I can go ahead and read it. Can you hear me?
Yes.
All right. So as consultants, what's the fastest deployment process y'all seen actually in an enterprise environment running in prod, and why was it so performant?
So it's going to be interesting. I can't say I've seen too many fast ones in enterprises. Typically, the best luck I've had is where we've had a lot more control of a team and what they do and how they work. And for new or greenfield deployment, where there wasn't a lot of legacy that they had to worry about, so where we could like spin off for a new project or endeavor or feature, use of Lambda was involved because we didn't have to worry about any other infrastructure. So it's typically like a combination of figuring out politically how we can take something that might be meaningful but not, core banking infrastructure, if we're talking about banking, so that someone will let us, in their eyes, probably have a bit of a play around with this new fandangle cloud stuff, where we get to control and rewrite how the application's written and the pipeline in which it's written. So pretty drastic changes to their like everyday way of doing business.
What was that time span, Drew? I think I missed that.
I'm trying to think of it like exact time span.
I can think of one from our last client. There was one team, they were focusing really heavily on their pipeline. They got down to like 2 or 3 days, maybe up to 2 weeks, just depending on the kind of change. But they got down to 2 or 3 days of production with all the various checks. We're gone from that client now. But if they kept on that progression, they were aiming for same day deploys, and it was definitely possible. They were on that path. I've seen same day deploys at small, medium-sized businesses plenty of times. And of course, in open source projects like the one we're about to demo. But yeah, in enterprise, like that 2 to 3 days is the fastest I've seen so far.
All right, thank you.
Good questions. So, okay, I think we've got one little thing to do to wrap up before demo time. So, just as the reminder, we're kind of following along the CI/CD flow, even with local development, and we were explaining all these types of things that you might want to do locally. So, what we're going to do now is we've got 5 post-its here, and we're going to try and figure out where they belong on the diagram. So, I'm going to pull one out and see if Chris can help me. So, unit testing with SAM for local serverless unit testing. So where would you like to put that?
Yeah, that should definitely go in the local.
No pipe, local. There we go. Yep. And sort of unit testing kind of early in this piece. Cool. Testing the website returns at 200 or even some sort of integration with another service.
It should totally be run locally. You've got a Lambda function. You should be able to, nope, this should be in local on your machine.
Okay.
You should know your Lambda function is going to work before you even commit it.
Okay. What about interacting with the application? We actually have the word there locally for debug, so I'm going to take that out. I want to debug my application running in the sort of environment it would run in, so not a unit test, but actually hitting it in the browser. So will I need like a QA environment for that, or?
Nope. Locally again, you should be able to do that locally. There's no reason that you should not be able to do that locally.
Driving a hard bargain. Okay. Linting in the IDE. Okay, I'm going to get that one right. That's local. Linting in the IDE.
It's probably production.
Production?
Yeah.
Let's see what the last one is. Copy pasting new Lambda code into the AWS console. Well, that one we can't do locally. And that one's probably going to, if we looked at the time frame, it's going to be kind of sitting in that few minute mark, maybe not a few seconds by the time we're done with copying and pasting and hit and save and getting through our wonderful AWS console and the great developer experience that is AWS console. Okay. Thank you all for following along on that pre-rehearsed drama piece about where we should be testing. So hopefully we've made the point that we think that you could do all these sorts of testing locally. Looking at your screen, Chris, and it doesn't look like it's updated, or maybe it's paused. Are all the post-its?
I see all the post-its in the right place. Does anyone else see it frozen?
Does everyone see all of the post-its in the one box, or most of the post-its in the one?
I'm seeing 3 post-its in the feedback box still.
Yeah, it looks like the screen's kind of frozen for screen share. Maybe you have to cancel screen share and start again.
Start it again. Screen share. All right. How's it now?
Looking good. Most of them are in the right box and the copy paste here there. Perfect. Okay. So apologies for that, but I guess hopefully we drove home our point. But we reckon you can do all this stuff locally. And with that, just one more question before I hand over to Chris. What's better than a fully automated pipeline? Local testing. Testing locally will get us there. I'm actually going to skip over this thing we called 3 Musketeers. Not going to subject you to that, but we're probably going to explain it as we go or afterwards. And I'm going to hand over to Chris now to set up and explain what his repository is, why we're using it, and then all the various steps following along on Miro.
All right, everybody. Thank you, Drew, for the presentation. We are now going to try and look at some of these ideas implemented. So we want to aim for those micro feedback loops. We're talking here about developer experience, right? We want to not just optimize for infrastructure and production, not just optimize for cost, not just optimize for maybe the most, the fastest running pipeline or something. We want to specifically focus on developer experience. This is something that doesn't really get thought of first and foremost a lot of the time, but this is a crucial piece that's going to help us speed up our development process and give our developers an environment that's just more enjoyable to work in. So they're going to get more productive work done. We want to focus on that developer experience. And a large part of that is those micro feedback loops. Let me pull this diagram up here again. Micro feedback loops. We've got these little loops. These are all, maybe unit tests, and then a little bit of a bigger loop. This is maybe our integration tests running like a locally emulated environment. A bigger loop, maybe we're doing a deployment to like a personal testing environment. And then there's an even bigger loop. We're committing it and committing it and getting it through the pipeline and merging it to master. And that's gonna, do another deploy and some more tests. And then if it makes it through that, there's another feedback loop, and that sends it to production, more tests, and then users are using it. It's about developing these concentric feedback loops. We want to focus on not just the big loops, which is often what we're focusing on. We want to make sure we focus on the small loops, and those lead into the big loops. We want to make sure that we're getting that feedback as fast as possible. Every time we're committing, and I've seen this recently, somewhere working out, I'm trying to work on these dashboards, and I have no way of testing this locally or by hand. If I want to update the dashboard, I can mess around with it in the UI, but if I want to test my configuration, I have to commit it to the pipeline, and then I have to wait for this 20-minute pipeline to run, and it's extremely inefficient. We must have these micro feedback loops where we can develop our code and test our code quickly without having to wait on a 10 or 20-minute pipeline. That's what's really going to make us those like 10x developers, the really fast developers, really getting code pushed and being super productive. So we're going to show you how we can do that with serverless. A lot of folks struggle with this. They really do. And we're going to show you just how easy it can be to get those micro feedback loops set up with serverless. So we've got this repo here, and it's already been sent out, but let me post it in the chat again. Please feel free to clone this down. Everyone should be able to run this. It's designed to be, used as a template. The idea here is we're going to use this pattern called 3 Musketeers, and I'll go into what that is in a minute. But we're going to use this pattern to develop this AWS environment. We're developing an application. It's a standard 3-tier app. It's going to have a front end static site. We're going to use React, actually, HTML, CSS, JavaScript. We're going to deploy that to S3, right, behind CloudFront. For the API, we're going to interface with an API. We're going to have a Lambda function. It's going to sit behind API gateway for accepting traffic, and it's going to interface with the DynamoDB for the database. So really a full serverless stack. In our infrastructure as code, we're also going to be configuring DNS. So we're going to do all these things in this one repo. Now, what's cool about this, and you very well may have done this before if you've messed with serverless or AWS, what's cool about this is we're going to make sure that this whole environment works locally. We do not want to have to wait for our pipeline to run or for our deployment process to run to AWS. We want to be able to test this locally before waiting on that. And that's what we're going to show you. So I'm actually going to go ahead and clone this down because I want to show you how easy this is. I want you to believe me. And I'm going to make a directory here. And let's call it the meetup. And I'm just going to clone this down. Get clone, if I can type. And we're going to clone that down. Now, if you read that, README, the first thing it's going to tell you to do is run a make install. This is going to get all our dependencies set up. I'm not going to focus on that. We're going to let that run in the background. I've got one of these already set up. So let's go back to the Miro board and follow along. So this make install, this is really going to make your life easy. How long does it take all of your projects you're working on? Please feel free to leave in the comments. If you had a fresh machine, tell me. How many hours would it take for you to set your whole project back up? Just, leave a comment and we'll see which project is faster, this one or your project. How long would it take for you to set up a new developer or a fresh install? This make install with the 3 Musketeers pattern, it's going to build a bunch of containers. It's going to get everything ready for the backend Lambda function for emulating everything. It's going to get all the dependencies, Node, everything ready for the front end. It's going to, you don't have to have Node installed on your machine. It's going to take care of all of that for you. Infrastructure as code, we're using AWS CDK. It's going to set all that up for us. We don't need to worry about figuring out how to install AWS CDK. We've also got some end-to-end testing here. We're using Playwright. We're going to get all of that set up too. It's going to do that for us automatically. It's doing all that with Docker, Compose, and Make. Those are the 3 Musketeers. So that's the setup process. While that's running, let's figure out how are we actually going to start diving into these feedback loops. So the first thing I'm going to do is show you what does this look like. Let's go to the repo real quick and let's check out this live demo. So this is what my production pipeline is deploying. This is what it looks like in production. I refresh it, see that user count going up. That's a Lambda function. That's cool. That's good. But now let's try to actually test this out locally. I'm going to run make run. That's the next thing that we're being told to do in the README. And let's see what happens. It's going to go ahead, and it looks like I had it running in the background already. Oops. It's actually killing the old environment that was already up. Give it a second to finish doing that. It's going to go ahead and spin up a new one for us. Let's actually see if that initial install, that initial install is actually, looks like it was about done. All right, so cool. We've got this up now. What's going to happen? Well, it's actually going to open up React for me. Here we are. This is my local testing environment. Looks very similar, doesn't it? This is exactly what we had in production. A little bit different though. It says hello demo here. It's a change I made. So let's see how fast we can change this. Let's have this open here. I'm going to flip back over here and let's start now to practice making a change. So, so we've got Docker Compose up. It's emulating the front end, it's emulating the back end, and it's emulating the database. We've got all these 3 things. Let's go ahead and make a change real quick now. So let's open up the front end and let's go into the source. And this is where our code's going to be. But before we make a change, let's be good developers. Let's make sure that we test our code. Let's make sure our tests are passing. I'm going to go ahead and run make test. Again, this is another layer of abstraction. It's actually going to run all those tests we just talked about and make sure they all pass. So we'll let that run while we look at our code. This is not just running the unit test. This is going to run the end-to-end tests as well. We'll find out what happens.
Green, you're looking good.
Yep, looking good. So let's go down and find that make demo line. Welcome to this demo site. We don't really want that anymore. Let's welcome to my demo meetup. I'm going to go ahead and save this and let's check it out. So
there we go.
did it
Yeah, updated welcome to my demo site right at the top. That's really cool.
Oh, there it is. Okay, I did the wrong line. I was struggling to see it. All right, so we see that works, but that's pretty easy, right? It's pretty easy to edit React like that. We can see actually that one of my tests failed because it was verifying the header said what I wanted it to say. What let's do now is let's aim for that first micro feedback loop. We want to get our unit tests running. So we're going to run our unit tests and let's see if they all pass or if we need to fix any of them so that we can get this change committed. We can actually see that we have one fail, but we don't want to have to run that command every time. Let's go ahead and run them in interactive mode. Let's go ahead and check out that test, fix it real quick. Instead of welcome to this demo site, and actually now says welcome to my demo meetup. Let's put this in here. And it's going to run. Let's make sure it passes. All right, it does. Let's check those end-to-end tests as well. And we're actually going to see how fast we can get this change to production. So in the end-to-end tests, we're going to go in here real quick. We're going to go into the tests, not welcome to my demo site anymore. Welcome to my demo meetup. I'm going to run this real quick. Let's see if we can get these tests to pass this time. Once we finish changing the front end, we're going to go ahead and try change to the back end as well. All right, and last thing we really want to make sure we do is make sure it passes the linter. Looks like it's all good. So we now see this looks pretty good here. It's passed all of our tests. We want to get it up to the into production, right? So we got to commit that, right? That's going to be the next feedback loop. Is that the case? Let's see. Change H1 heading. So our pipeline, maybe that's going to take 10 minutes or something, but wait a second, we can get a faster feedback loop than that. We don't want to have, we've seen it, our unit tests pass, our end-to-end tests pass. We can visually confirm that it looks good, emulated locally. Again, this is all running on localhost. It's using our API as well. But we want to go ahead and probably deploy this as well. We can get a faster feedback loop than deploying it through the pipeline. Let's run a make diff. It's going to see if it can detect any changes between our infrastructure that we've got in our infrastructure as code in the repository, which is actually defined right in here. You can take a look at it if you want. We're going to check that, and then we'll go ahead and run a deploy. Cool. It doesn't look like anything is going to be in the way. Let's go ahead and do deploy, and it's going to go ahead and deploy these new changes to the front end. So while that runs, let's start looking at the back end. So we've got this Lambda function here. Let's mess around with that as well while we've got the front end deploying. This is where things really get cool. So let's go ahead into the back end, and it's still called Hello World. I actually used the SAM Hello World template for this. I wanted to keep it as simple as possible. So how this is grabbing that user count right now is right here. We're going to refresh it. It's actually querying the DynamoDB, which is running locally as well, and grabbing a user count. So I'm going to mess with this. Let's just say we made a typo or for some reason hard-coded it and didn't mean to leave it. So I'm going to save 100 right there. I'm going to refresh the page. Again, locally, I didn't need to do anything. It's working automatically. This is what a lot of people struggle to get working. We've got the whole environment working locally. We can see the second I type a change, it's immediately visible locally. And then let me go ahead and and run my tests. Let's do a make test end-to-end. Let's see if our end-to-end tests are still working. What's going to happen here? All right, they passed. Let's run our even faster feedback loop. Let's run our backend unit tests and see what's happening there. Looks like they're actually failing, and they're failing because we hard-coded that value in. And the unit tests, which let's dive into those real quick and show you what they look like. The unit tests are actually checking specifically for what happens the first time we hit the counter, and what happens when we start iterating. So we know we hit it twice in a row. What's going to happen? So these unit tests are failing. So I'm not actually going to be able to deploy successfully with a hard-coded like that.
So the reason why they're failing, Chris, is because your tests are expecting that the very first time the answer is 1, and when the variable had a count variable, it would have said 1. Because you override that to 110, 110 is not equal to the 1 it was expecting in the test, or 2 if there were 2 users. And so it's catching that for you in the test that you've written, right?
Correct. I'm catching that. I'm not having to wait on the pipeline to catch something like that. I can catch it easily with my unit tests, and I can verify that I didn't break the integration with my end-to-end tests. And so we're getting a demonstration of that microfeedback loop. I just fixed this. I know that I know that my backend is working because its unit tests are passing. And I know that the integration between the two is working because I can run those end-to-end tests. And that I also know because I can visually double check that it's working as I expect it to.
So many
all of those
feedback
things.
loops. So many feedback loops for you. We have a few questions for the audience, and they are related to testing. So do you want to field some of them now?
Yeah. So let's take a look at from Brett. This stack works great with API Gateway and DynamoDB. But will the stack work with other common services like Cognito, SNS, SQS? How does the approach compare to something like local stack? So this is just one way to do this for free. It's easy. I'm not saying this is the best way. I'm just saying that we need to make sure that when we're setting up our environments, that we focus on those micro feedback loops. So whatever it is you need to do to get those feedback loops down, that's what you should be doing. Focus on unit tests work, but if I want to test that my application works, and let's say I have Cognito integrated, which I don't right here, I need to be able to verify that that's working very quickly. We want to hit that, verify those integrations are working. Shouldn't take more than 15 seconds, wait time or something like that. And we want to be able to run those end-to-end tests locally as well. We shouldn't need to wait 10, 15, 20 minutes for that pipeline to run before we find that out. Local stack, Brett, is a very viable way of doing that as well.
Yep. And I think, Chris, when we were talking, you mentioned that a year ago, there wasn't as many available AWS services to mock. So it was really difficult to do something like this feasibly, cover an actual serverless application. But in the last year, what you've seen is that more and more services are available for local testing, right?
This exact setup was possible a year ago, but about 2 years ago, it would have been much harder to do. So the next feedback loop that we've got here is actually,
that was Brett's question. Let's do one more while we're here so we don't forget. Alicia, and she asks, what do we think about Gherkin features for testing? So
yeah, I think Gherkin's great. Gherkin would fit right in to this setup. You could very easily use that for running or for writing your integration tests, and it'll plug right in with a number of end-to-end test writing tools. That would be a great thing to use here. Again, this tool set I'm using here, this stack, I'm not saying this is the best stack. I'm not saying it's the only stack. I'm just using it as a demonstration of those micro feedback loops. And this is one easy free way to do that. A lot of the local stack services are paid for. For example, API Gateway is not free. So I chose to use AWS SAM. Now, for the question of how do we do this with something like SNS or SQS, that's where we really need to make sure that we spend the time to focus on the developer experience. It's not going to be as easy to emulate those. you might use local stack. And I don't know which of those specifically are paid, but you don't have to run all these locally to get the micro feedback loops. Every single developer can have their own development environment. And that's what I've got right here. AWS demo, this is the one that's deployed from the pipeline, but this meetup, chrishart.cloud, this is what I deployed locally. I just deployed this. Welcome to my demo meetup. Remember we made that change? That's not in production yet. Well, it actually might be. I don't know. Okay, well, it is now because the pipeline finished running. But
so you're saying we've done mob programming with 17 people, and all of us have got to production with this change. Then,
yep, it's there. It's there. It's been deployed. It really was that easy. We can even see that little bug that I wrote, hard coding 100, that made it there as well, because this is my local deploy. Let me show you the config file so that you believe me. This is my local deploy. That probably took, I don't know, 30, 60 seconds, something like that. Meetup.chrishart.cloud, there's my environment variables. This is another feedback loop. I don't need to wait on that 10, 20-minute pipeline to run. I can actually deploy this to specifically my developer environment. That's the next feedback loop. You might have local unit tests, then you might have the local environment with end-to-end tests, like just like you can see right here. And from there, you might have a personal environment that the developer can deploy to from their local machine, but that doesn't affect anybody else's environments in the cloud.
That's
After
really cool.
that, we've got another one. We've got the pipeline. The first development environment in the pipeline. And after that, maybe you add more tests on. The idea is getting the feedback as fast as possible. The most important feedback first, as fast as possible. We want to make sure we optimize.
So I think that might be a good time to pause, because we've shown so many things in this demo, from like unit testing to end-to-end testing, deploying to our own environments and deploying to production before the pipeline and through the pipeline. So there's a lot there. We even heard from the audience questions about how we can expand this out to other services. But also, I know something, Chris, that you've been wanting to do around BDD and introducing Gherkin. So that might be the next feature or pull request that you accept on your repo. Thought that might be a good time to at least kind of wrap up that portion and maybe see if we've got questions from the audience. They might want you to run some other commands or ask you other capability here. So maybe you open it up to the audience for questions now.
Yeah, real quick, one more point. With the local developer environment, remember the focus isn't to make sure everything is running locally. The focus is to get those super fast micro feedback loops. There were ways to do that with everything running in the cloud. Just make sure you make that your goal. Not having everything locally, but make sure your goal is the micro feedback loop. You'll probably end up with a more complex local development environment that includes some things running locally, like API Gateway and Lambda and Dynamo and S3. And for some of those services, like Cognito, which you might not be able to emulate locally, or you might have to pay for local stack for that or something, you could actually have, that's where your personal developer environment comes in, and you could integrate those two things. Even in an enterprise, this can work with individual accounts. And you integrate with that piece, yes, it's in the cloud, but you can still deploy updates to it very fast in 30 seconds or something. You're probably not changing Cognito all the time. So you can combine those two things.
So let's see, if you've got questions, you can put your hand up in Zoom. You can ask on the chat. I know we've got a few familiar faces on the call as well, so don't make me call you out by name to ask a question. No, I'll do it. While you're thinking of questions, Chris is showing off his fancy test reporting in Git, which is really cool.
Ooh, fancy. Looks like Christy has her hand raised.
Christy, go ahead.
Hey, yeah, thanks for that presentation and for the introductions. I appreciate it. Definitely newer here, but I could either be your favorite or your worst nightmare here, because this is exactly what I do. Like in my day-to-day is I work for Liberty Neutral, and I do like all developer experience and serverless enablement and DevOps for like 5,000 engineers. So I'm kind of curious about the pattern aspect. So I know you mentioned you used like this 3 Musketeers pattern. Is that something that you're doing just for open source, or is that also like at an enterprise level?
3 Musketeers is a brilliant invention because it's an Australian one. and I grew up in Australia, so that's what the tick to that was. Three Musketeers is simply a pattern that essentially shows us that we can use make and compose and Docker in a certain way to achieve consistency across anything that we do locally or in pipelines. And what we found in the industry, I've been using this for, I can't remember now, 5 years plus since I discovered it, is that we found that a lot of people are naturally using one or two Musketeers for sure. Like a lot of people in pipelines are probably Dockerizing components of them. Most modern build systems take advantage of that. And these patterns is just like a nice repeatable way. So no matter what repo you use, you can clone down the repo and know that if you want to run a build, you run make build. If you want to run a test, you run make test. So it's just a series of conventions in that way. I use them for all the repos I make. That includes personal projects, people on my team, clients, whenever we're introducing it, whenever we can, we kind of introduce this concept. A few years back, it was a bit more difficult with the enterprise because is Docker even allowed on your workstation? But what we're seeing more and more is it's becoming commonplace.
So I kind of have a follow-up to that with the pattern then. So what we're seeing is like, you kind of have two fields of users, right? So we have a lot of like beginners that this is a great place to start, but what we're finding is then they're like, this is a lot up front for them to know out of the box. And so, we're kind of hitting this like day two development where like, they're like, well, this is great, but like, I need to add this and this and this, but like, what the heck do I do? And then on your other side, you have like your really advanced users who would say that something like this is more opinionated. So like, hey, maybe I'm getting Python and Docker and these things, but I really wanted to do this in TypeScript, or, maybe I need to use something that, maybe I can't use Dynamo and I have to connect to an RDS database or something like that because I'm migrating something or whatever.
Sure.
So like,
Yeah.
how are you handling some of those use cases? Like, are you saying like this is a starting point and then you have to go through and delete things and clean stuff up and move things around, or like, how are you kind of handling that?
So let's think of the two layers, right? So the first one is the Three Musketeers is just the pattern for how we run the arbitrary commands. So no matter what you want to put inside of your Docker container, whether you're using TypeScript, Golang, Gherkin, any particular step to do anything, the pattern pretty much holds true. It is opinionated. So if you get to a certain team or org and you're like, I don't really want to use make, I want to use something to wrap it instead of make, that's not really a big deal. The key here is consistency through Docker and one interface that your team or company can agree upon so that you can have a little bit of consistency when you're going between local and various projects. But that second kind of part of your question is like, what if I don't want to use a DynamoDB for my application? That's more of a question of app development. And I think what we're demonstrating here is an example application and how we could use that example application in the cloud to ensure that we test this locally. So you could use whatever you like as a team, right? This is your team's repo and your team's infrastructure. So you would probably put in whatever you wanted there. So it's not to say, clone this down and everyone in your company uses DynamoDB. But if I could be opinionated, I would say everyone uses Three Musketeers.
Yeah, if I can add to that, right here, Christy, we've got the DynamoDB container spun up, and there's a very small amount of work, set up to integrate with this and spin it up. We're filling a table in at the beginning every time it spins up. There's not a lot there to make that work. You could very easily pull out DynamoDB here, put in MariaDB or Microsoft SQL or Oracle or whatever you want, and pop that out. It would be a pretty simple thing to do, changing out the database technology. On the other point about entry-level developers, that's just a matter of, I think, thoroughly documenting the solution. If there's no senior devs on their team to help them out, just make sure that the way you've implemented is pretty well documented and it's well organized. For example, this repo could be even better organized, but at least everything's compartmentalized, and there's a separate README in most of these directories, not the end one, but for example, here in the back end, there's separate README. You could set up some guides that explained, okay, maybe this is a template stack you're using across your org or something. You could have documentation for that for the junior devs.
Yeah, the challenge is getting them to read it, right?
Right.
And not
That's-
fielding 10 questions and say, oh, it's back in the README. Just check the README.
So one of the things that we wanted to convey, right, and it might be difficult until you give it a go, but I would love to have you or others actually give it a go. One of the things that we wanted to convey is that Chris is like a new developer. If he clone this repo, using the Three Musketeers convention, he knows that when he runs make, he gets all the possible targets there, and there are some common ones like build and deploy. So if he wants to build and deploy this locally, he just needs make, he needs Docker. And then after that, he doesn't need all of the requirement components within that. He doesn't need SAM, he doesn't need Node, he doesn't need Python. All of that's handled by the pipeline abstracted in Docker. So if he wants to, he can be up and running fast without much knowledge of how the app works. But at the same time, and I love the point that you're kind of bringing up, at some point, if he's going to deploy this to production, he needs to know how it works, right? He needs to understand Node and Python, right? And that's not really being abstracted away from him in a way that he can't figure out what's going on. So he's got his make file and his Docker files that shows how everything's being built. And kind of to Chris's point before, he's got the backend folder, the front end folder. At some point as a developer, he'll need to go in there, understand how this works. And there's no magic way to teach you how an application works. So we're not trying to say like this repo is the repo for Lambda deployments. It's the perfect way to do it, right? We're just showing the wrapper and the pattern around that proves that you can test this locally, and that you at least don't need to spend an hour or a day or two just trying to get, Chris's damn repo to work. If it takes you longer than a few minutes to get Chris's repo to work, he's failed and he wants you to give him some feedback on it. It should take you a few minutes to get started if you've got Make and Docker installed. And then if you need to learn how Python and Node work, then there's no magic solution for that we know of today.
Yeah, I asked you the tough questions because we're in the same boat, like we're doing pretty well with the day one development and the getting somebody in production pretty quickly. But yeah, it's the next, we're taking it the next step. I don't have the answer, but yeah, the day two stuff's definitely a challenge.
If I may
go
throw my 2 cents in, I think the answer is that it's hard for someone who's thrown into a stack to get an understanding of the full stack. If you want the developer to really understand what's going on, you need to guide them through building it themselves so they understand, intricately how the various pieces work. And that might be the answer. And you might need to take developers and put them aside for a week or two to really drill into them how the stack works. And if they don't understand how, maybe the cloud works, then there might be some extra work to go into there. But they need to understand each of the component pieces if they want to become an expert at it. I mean, there's not really going to be a way around that. So
there is a consultant answer to this. There's a non-technical answer to this. You may or may not like it. You may or may not agree with it. But the answer is pair programming. It's it's the fastest way to do knowledge transfer. And pair programming meaning not we're both working on code when there's a problem, meaning like we start development as a pair. We work all the way through until we're finished. And that's one of the easiest ways to get knowledge transferred and create cross-functional teams where you're learning different skills or learning different parts of the stack. So that's my little consultancy answer that we live and breathe above and beyond making the repo so damn easy that if you know what you're doing technology-wise, you don't need to learn, how Chris wants you to do it, right? If Chris needs a certain version of Node and Python for his stack, I shouldn't need to kind of figure out how to make that work on my Mac or my Linux machine. I should clone his repo and just run a make build or make deploy.
Yeah, thank you. I could talk about this all day, so I'm going to cut myself off here.
So we really appreciate the questions.
Yeah.
Were there any others from the audience? We've definitely got time to stick around.
I was just curious. You said that it doesn't have to be Make, Docker Compose, and Docker. Have you seen anything else being implemented in those places? And
yeah,
possible.
So I should clarify. Docker is the critical component there that's going to achieve consistency, unless you run some other container based system. But Docker's the popular one of choice. And it kind of actually it's a layer that goes from there. So you need Docker for this pattern. Docker Compose is just a really nice, neat way to run Docker, which is easy to read. So it's more about readability. And then Make is usually, I guess, what we would call the most contentious part. So make is the interface. It's what Chris is showing you on screen now. The reason why we choose and talk about make is because it is easily accessible and multi-platform, most accessible to Apple and Linux users and WSL. But it really doesn't matter as long as it's accessible for your whole team or company, depending on how far you want your movement to go, right? And it needs to be ubiquitous. It needs to be that whatever machine you get as a workstation, you kind of have it then and there. So if not make, I mean, you could write a simple library in Golang. I know there's a few other make-like alternatives that's mentioned on Three Musketeers websites as well. I can't remember them off the top of my head, but they're kind of build type tools. You could use Python if everyone's got Python.
Gradle or
even
something like that.
You could use Gradle. I've not seen people use that, but I know Java people will say, hey, you know, we're mostly a Java house. Why don't we use
Gradle
Gradle?
everything.
You could really, if Chris, can you open up the make file? He's got one of the most complex Three Musketeers ones I've seen, because he's essentially got a number of different services. But when I say that, if you go to any one of the targets, your make targets, Chris, that have like Docker Compose command. So if you look at like a build container or any one of these, yeah, just stop right there is good. If you look at these, most of his commands are run a compose file and run a simple one-liner afterwards, right? So you can use any system you want that can wrap the most basic one-liner. Every one of these build commands is simply just a one-liner. Now, the key here is if you're not using an agreed upon interface like make or like Gradle or whatever, then where are you putting this stuff? Most people would put this stuff in a README or in Confluence or in the senior developer's head, or everyone just has to figure it out as they go. And what we're saying is codify. Codify your things so that you have an agreed upon convention, a wrapper, an interface, and makes just one of the simplest, most obvious, ubiquitous ones we could pick.
Makes sense. Thanks.
I will add in, this specific repo has been tested on Linux, on a couple different distros. It's been tested on Mac, and it's been tested on Windows with WSL. And it does work, you know, as long as you have make, Docker Compose, and Docker installed, it just works.
Yeah. But yeah, so just remember that, like I would definitely, I've definitely only used make and only found a need to use make. But if you can get your whole team or teams or company to agree that they've got something else that's better that can simplify this, then that's fine too, right? But you do want to be running Docker just to make sure that you've got the consistency, and you want something that can execute commands like what you're seeing here, which are really just Docker Compose or Docker Run commands more than anything.
Right.
And you will see some conventions. The underscores here are what's running in the container, and the things without the underscore, that's the Docker command. So the really cool thing is if you've got like a really annoying person in your team, maybe they're a Jordan, I'm just going to pick on you, mate, because I can. And he's like, I don't have Docker, I don't want to use this stuff. You can actually run make underscore test front end. And as long as you had NPM installed, it's going to do the same thing as what the container could do. So if you're having problems with Docker, if you don't like Docker, if you just want to run this stuff locally without the Docker component, this pattern actually just has a really nice way of doing that. And Chris has adhered to the pattern really, really well with that underscore. So, you know, we'll share out the link for the Three Musketeers website, which really just goes through what they've learned over the years by using the pattern and what we as contributors have also learned. But it's served me well for many, many years now, and we definitely converted Chris in short order.
Yes, it's the pattern really is pretty amazing. I've done something similar at a previous place, using just Bash and Docker, and then we had a bunch of microservices, so we wanted the full development environment spin up. Well, you run this Bash script and it'll spin up all the various containers. That works, but this is a lot cleaner and more extensible.
That makes sense. Yeah, I've seen it where, workstations are kind of bootstrapped using something like Homesick, and then all the services are there. But to me, it really just makes more sense to put the instructions to get the environment, your local development environment up and running within the actual code itself. So love the point about codify all the things. If I can pull the repo, run a command, get the entire environment running, then it's just a better experience for the developers and ultimately a much more productive experience, for the customers we're trying to provide value to.
I'll actually show you in the pipeline. I started on this, I didn't get very far, but I was actually starting on a test which will do the full initial setup in the pipeline to verify that in the pipeline on every single commit to master or feature branch actually either, that we didn't break that initial setup functionality. You should be able to clone the repo down, run, make, install, get all the commands, run, make, run to get the local test environment set up, run, make, test to verify everything is green. And we should be able to have a pipeline that verifies that we don't break that. And it means that if you break something, you can very easily blow the whole repo away, clone it down, and be exactly back where you started in 3 minutes.
So powerful.
Yeah, Chris is actually so obsessed with the developer experience that he wants the first clone of this repo for each of you, to be the quickest experience possible. And he's gone so far as to say he's going to have a specific test in his pipeline to emulate the first time use, because he wants to know about the error before it ever gets to you. So it really is true. Like, it's a work in progress, but if you have to install anything other than make Docker Compose and Docker to get this to work, if there are any errors that load up and you can't load the website locally on your machine, Chris wants to know about it. It should take 3 minutes to download all of the dependencies through make install, and it should take about a minute to deploy that Lambda and React app locally. So if it takes you longer than 5 minutes after you clone this to actually see a local working app, then Chris will give you all of your money back. Yep.
Every cent of your money back that you paid for this, as long as it was $0.
But raise an issue and he'll have a look at it. He'll probably pull me in and we'll do some pair programming.
Very nice. Let's see here. Any more questions from the audience before we go ahead and get into the wrap up? I agree, Matthew. Awesome job, guys. Thank you so much, Drew. Thank you, Chris. This has been great. I really love the emphasis on shortening the feedback loops. I think a lot of people that work in the Agile world, we think of it as like, oh, let's have the demo, more soon. Let's get feedback from our shareholders. But the feedback loop starts much before that. The feedback loops start way before that, on your development machine. Something as simple as running the integration test saves so much time. Context switching is just a killer. After you start to get rolling in your development task, to wait 20 minutes is basically just, lose an hour almost, it seems like. So this is definitely good stuff. In the teaser for the meetup, we did promise a quick trivia session. So if anyone can drop the second AWS service released in the chat, I will send you a code for $50 in AWS credits.
I think I know what it is. I'm gonna
guess. I'm not gonna Google it.
Yeah,
Okay, a hint. It starts with S, but it doesn't end with a number.
Oh, okay. Then I don't know what it is.
SQS.
There we go. Yeah.
Oh, there we go. Winner.
That's true. Yeah, so SQS was released after S3, but before EC2. Surprises a lot of people. A lot of people think EC2 was either the first or the second. It was the third. So Jose, I will go ahead and drop you a code in the chat privately. And so with that being said, just to kind of wrap this up, thank you again to Drew and Chris. This really has been great. We've got the recording going on, so I'll go ahead and close that out and look for that on our YouTube page, the AWS Meetup Group YouTube page. So if you want to come back here and compare notes, get some tactics that maybe you missed today, well, it'll be around in perpetuity. So with all that being said, Jose, do stick on the line and look out for some new content coming out from us in the near future. We do not have anything scheduled. However, we'd love to hear back from the community as to topics you'd like to hear from, or if anyone has a talk that they would like to give we're always trying to grow the community in terms of presenters and members. So just let us know, drop us a line on LinkedIn or in just a private message on Meetup. So with all that being said, hope everyone has a great night. And thanks again to Drew and Chris. Fantastic job.
Thank you.
All right. Hope everyone has a good night.
See you all later.